2,000 watt pure sine inverter, almost 2,000 watt hours of energy, charge rate of close to 2,000 watt ability. Batteries will last over 10 years with daily cycling. Portable. This is hand carryable. But before I can go into details on this solar generator, I need to explain how I got to this point. A few years ago, I was thinking about building a portable solar generator to power the critical loads in my house in case of long-term grid failure. I did consider a gas or propane generator, but quickly realized it had too many drawbacks to be feasible. I do have a 5.5 kilowatt hybrid solar system, but the battery is only big enough to power the house for about 3 hours, at least until my power walls get here. The first thing I had to figure out was what critical loads will need power in the house. After thinking about it a while, I decided that lights, microwave, TV, computer, cell phones, etc. would all be nice, but they weren't what I would consider a critical need. I asked my eldest daughter what she thought would be a critical need. Without hesitation, she came up with the same thing I had: the refrigerator. Most everyone in the United States have at least one refrigerator-freezer combo. I have one and also another standalone freezer, but for a long-term critical load need, I will only consider the refrigerator. At any given time, I will have several $100 to over $1,000 worth of food in the refrigerator that I wouldn't want to go bad if it was to go without power for an extended period of time. Now I need to find out how big a battery I will need. My refrigerator is 25 cubic feet, has an ice maker and water dispenser. I bought it in 2009, so it should be fairly efficient. I ran several tests on its real-world power consumption because I found out that many solar generators and other companies exaggerate their product claim of what it can do in the real world. Power usage of a refrigerator can vary greatly, depending on things like air temperature, how often you open and close the door, how much warm food you put in to cool down, and several other factors. On mine, I found it would use at least 1.5 kilowatt hours a day, and could double that depending on how it's used. So I needed a battery that can supply at least 1.5 kilowatt hours of energy, not rated at 1.5 kilowatt hours, but can actually supply that much energy to the refrigerator. I need to stop here for a second and explain the difference between watts and watt hour. There seems to be a lot of confusion about it. The easiest way for me to explain this is to consider watts as instantaneous power. Like my inverter can produce 2,000 watts as soon as you turn it on. Watt hour, on the other hand, means how much power was used over an hour. So if you turn on a light bulb, it instantly is using 100 watts. And if you leave that light bulb on for 1 hour, it will use 100 watt hours of energy. Now, say you turn the light on for 30 minutes, then turn it off for the next 30 minutes. Then in 1 hour, it will have used 50 watt hours of energy for that 1 hour time period. I hope that helps. Okay, back to the project. I didn't want to spend too much money on this project, and at the time didn't know that much about batteries. So I was thinking Costco has these marine lead acid batteries for $85 a piece. Not as good as lead acid solar batteries, but better than a car battery. I never did find out how many amp hours they were listed as having, but I assume around 90 amp hours. And 90 times 12 volts is 1,080 watt hours of energy. One would not be enough, so I got two. So 2 times 1,080 is about 2.16 watt hours of energy for 2 of these batteries. They were also 55 pounds apiece, so 110 pounds. It just so happened I had been on Kickstarter and got a 1,000 watt inverter called a Sun Raiden. A 1,000 watt, 2,000 watt surge inverter is what I would call the minimum size for what I would need. It won't power all my household devices, but it should handle the refrigerator. This inverter had 2 connectors on it where I could directly connect a solar panel. It also came with 4 12-volt 3-watt lights that plugged into the inverter. I bought a plastic box to put the batteries in and mounted the inverter on top. I didn't want the inverter inside because of the heat it would produce, and I didn't want to add fans. A few cables and connectors, and it was complete. For less than $500 for everything. Tying it on a 2-wheel cart is how I moved it around. At 125 pounds, it was too heavy to carry by hand. So how did it perform? I had an oxygen concentrator that uses about 300 watts continuously. Using my kilowatt meter, it lasted about 4 hours before the inverter shut down. In normal use, you shouldn't use more than about 50% of a lead acid battery, or you'll substantially reduce its cycle life. But this is just a test. 1.2 kilowatt hours, short of my goal. This system would not meet my minimum requirements. As I learned more about batteries and from using them on my solar system for several years, I learned that lead acid batteries are not a good solution. They have many drawbacks. One of my biggest concerns is the weight of these batteries for the energy they contain. I would test these batteries downstairs in my office. Then in the morning, tie the battery box onto the 2-wheel cart, haul them up the stairs, down my outside stairs to charge them up with a solar panel, then take them back in the evening. This got to be old real quick. With the cart, this system weighed about 140 pounds, up and down the stairs every day. You could say this system is portable, but to me it really wasn't. After watching about every video on YouTube and gleaning all the information I could on solar generators or power stations, I couldn't find one single system that would meet my requirements. So I would have to build it myself. I had to redefine some of my goals. The inverter needs to be pure sine wave. It has to be large enough to handle anything that a standard household plug can handle, about 1800 watts continuous. I still wanted a minimum of 1.5 kilowatt hours of usable energy. I planned on using the solar generator every day for about 10 years, so I needed it to be capable of cycling that many times. It has to be capable of charging quickly, less than 4 hours for this large size battery. It has to be portable, hand carryable, no cart, no wheels. An average person should be able to carry it. A tall order? Yes, it is. But considering that battery technology is improving every year, it won't be long until my system becomes obsolete. How did I determine what hand carryable means? Why no wheels? I was buying dog food for my dogs at Costco one day, and I noticed that the bags weigh about 55 pounds. And even the bags were pretty bulky. Average people still didn't seem to have any problem putting them on their cart. So I decided that 60 pounds is the maximum an average person can carry. My 11-year-old daughter has no problem carrying the solar generator. So if it's over 60 pounds, it's too heavy. Under 60, good to go. My solar generator weighs 57.5 pounds. Why no wheels? I wanted this solar generator to be able to go camping, take it to a neighbor or a friend's house with only your feet, and only a single person needed to carry it. Have you ever had to haul a 2-wheeled cart through 6 inches of mud? How about 18 inches of snow? How about swollen streams or over a bunch of 4-foot rocks? When I was watching the terrible disasters in Houston, Florida, Puerto Rico, I was wishing somehow that there'd be a way to give them a system so they could at least power some of their things while they were waiting for help. But you saw the standing water up to their knees or higher in many cases. A wheeled cart would never be able to go in those kind of places, but a hand carryable one could. I'm using a 2000 watt Cotek 24 volt inverter with 3500 watt surge capability. It has performed great so far, has handled everything I have thrown at it with ease. Even my hungry 1800 watt microwave ran for long periods of time. Flooded AGM, gel, all types of lead acid batteries are out for many reasons. Lithium is really the only choice for now. But which type of lithium battery? There are 3 basic types: lithium cobalt oxide and a nickel magnesium cobalt oxide, or NMC, are high-density lithium cells used in things like electric cars, cell phones, things you want to have lots of power and little weight. But there are drawbacks to these type of batteries. You have to have a really good heating and cooling system with a good BMS. Tesla does a great job with its liquid heating and cooling system, and I'm sure they have a great BMS too, which helps with the second problem. They only cycle about 500 times on average. That's okay for a cell phone you might only keep for a couple of years. It won't work well for a home solar system. You want to last over 10 to 20 years. These batteries can also turn into flamethrowers if it doesn't have a good BMS system or it fails. My choice for a generator is a lithium iron phosphate battery, sometimes called LFP. This type of lithium battery doesn't have quite as much energy density as the other two, so it's a little heavier, but still several times lighter than lead acid. They are safer. The most important feature is that they can cycle many more times than the other two lithium batteries. The spec sheet on my batteries say it can cycle 3,500 times at 80% depth of discharge. Baby them and you can probably get several more thousand cycles out. The coolest part of this system is the BMS, or solar BMS, as Electrodacus or Dacian calls it. I spent months looking for a high-quality, small, powerful BMS to run my system. I couldn't find one until I heard about Electrodacus' Kickstarter project. Actually, this is his third SBMS project on Kickstarter. It took a while for Dacian to design, build, program, and deliver this SBMS, but it was worth the wait. It's amazing. It can power a house. First, it has a color display that gives you several screens of information on what's going on with your system, every detail of each battery cell, even graphical. Solar power input, battery information, load status, down to milliamps and milliwatts. Resettable counters for everything. It's totally configurable. From 3 to 8 lithium battery cells or capacitors of any type and size. Too many features to discuss here. The most important features are that it can handle up to 144 amps or 3,500 watts of solar panels. And it can handle 144 amps or 3,500 watts of load internally and up to 500 amps externally. That's more than a 10,000 watt inverter. I use 72 amp hour batteries in my system. So 72 amps or close to 2,000 watts is the maximum I could charge my batteries. But for long life, 1/3 C or about 24 amps is what I will use. When I tested my battery with this SBMS, it actually had over 74 amp hours of energy, or over 1.9 kilowatt hours of usable energy, way above my 1.5 kilowatt hours minimum that I wanted for my solar generator. I think Dacian is still going to make some more of these. If you're interested, go to electrodacus.com and check it out. I have a single solar panel that I can use to charge the batteries. It's a 225 watt panel. The SBMS doesn't use MPPT or PWM, just constant current. It was charging with this solar panel at 220 watts the other day. On a cold day, it will go well above its rated power. This panel has never charged a battery over 175 watts before. Just another benefit of the SBMS. I don't normally use that solar panel to charge the battery out of convenience for me. I have a universal power supply that I've hooked up to my system. When my main solar system is powering the house and sending back power to the grid, I simply charge the battery with a universal power supply. I set it at 24 amps, 1/3 C for the batteries. I have net metering with the power company, but they give me 1/3 the amount that they charge me for power that I send to them. So even though the universal power supply is only 88% efficient, it still saves me money using it. You might have noticed that the solar generator is kind of big. Well, I designed it that way for two reasons. One, I needed the room on top for the inverter and the SBMS. And have you ever noticed that most solar generators have no storage space? They don't operate by themselves in a vacuum. You need things like extension cords, lights, 12, 24-volt connections like cigarette lighter connections, USB ports, and other things you might need in an emergency. Even clothes, blankets, portable radio, or first aid kits. You'll need some of these things, and you can keep it all together inside the solar generator instead of having to carry it separately in different containers. One more thing, the solar generator meets my minimum power requirements to run my refrigerator, but it won't power my oxygen concentrator all night as it uses a little over 2 kilowatt hours of energy. So I decided to build another battery, the same size as the solar generator, with another SBMS 120. I connect the two batteries together and now have almost 4 kilowatt hours of energy. The entire system isn't cheap, but still about $1,000 less than something like a Gold Zero's Yeti 3000. Saving less than 25 cents a night, it will take a while to pay for this system. But the main reason I have it is for long-term power emergencies. So that gives me some peace of mind. Now I just need to figure out how to make it EMP proof. I haven't seen another solar generator that can do what this system can do. That is why I call it the ultimate solar generator.